Hello, my name is Shane Stevenson. This is the introduction to my project, which I'm going to be sharing with you. It is mainly about estimating favorability ratings for politicians using Twitter data. All right. So I'm about to get into the project scope. What I want to do real quick is I just want to impart that this project isn't trying to replace traditional polling methods. It wants to supplement traditional polling methods so that we can estimate the favorability that a traditional polling method would rate the president in the future based off of his tweets in any given day. All right, so I'm sure as you all know, political reporting is big business in America, especially with all of the craziness that's been happening in our political sphere. Political reporting is becoming more and more important. It's becoming a bigger moneymaker for news outlets in general and blogs and everybody else, right? For measuring favorability, most political reporting uses traditional polling techniques. With the advent of social media and how much social media has been picking up and how much social media data we have, especially with the current president that it tweets like almost 10 times a day, and other politicians like that, there is a lot of space to be made of using the social media data to measure various political metrics, right? Techniques like this are currently being led by blogging and reporting outlets like 538 by Nate Silver, who's really big in both the political sphere and in the data analytics sphere in general. And as I said, we're not trying to replace traditional polling techniques, but what we want to do is use social media with traditional polling techniques to be able to give us a quick, fast estimate for how favorability is going to change just based off of 1 day's worth of Twitter data. So with this, the big key thing here is that Twitter is becoming an increasingly critical platform for politics in general. Almost every politician has Twitter. Almost every politician makes at least daily tweets. And it's a big part of how politicians interact with their constituencies nowadays. So especially with the president, I chose the president because the president is infamous for Twitter, right? He currently has a ton of Twitter data since he's taken office, which makes the project easier to do for him. But hopefully this project will provide very easily generalizable methodologies that can then be applied to pretty much any other politician you want. It's an extremely important problem because politics is important in business and in our general lives. And being able to measure how favorable a politician is or how favorable a position is in real time quickly is an invaluable skill. All right, so for the business understanding, the domain of this project is politics, but the business area is political reporting and projection, right? So what we want to do is we want to develop a model that we can use, or a class of models really. The favorability one that we're working on here is just one of many that the business is going to want to develop. But we want to develop a class of models that can give us quick, easy estimations of a political metric at any given time. And then we want to use this for reporting and for selling to other news reporting outlets so that they can be on the edge of what's going on in American politics and on the edge of how things like favorability are going to change quickly. One of the most important objectives for this is mapping out topics and themes in the president's tweets and exploring how they're related to perceptions of his performance. So what we want to do is we want to comb through the tweets and find a certain number of topics that he talks about and be able to classify each tweet by the topics that are in it, and then use that to be able to give a quick summary of what the day's tweets were about. As tweets occur in real time, the model will allow real-time assessments of the current political climate. With the way that social media and the internet has people nowadays, everybody is looking for real-time assessments. They want to be able to say, right now, this is what it looks like is going to happen. big problem with traditional polling techniques is they take days. Most polls run 3 to 5 days long. So it won't be able to give you an accurate estimate of how people feel about a politician or a policy or a proposal immediately. And what our business is looking to do is correct that and provide fast, reliable political reporting. For the business objectives, the primary business objective is to build a model that can predict movement and favorability ratings based off of tweets in a given day in real time. The second business objective is going to be to identify topics and themes so that we can summarize and categorize tweets to provide quick overviews of what's going on for our customers. And the third business objective is going to be to create easy and intuitive ways to visualize and present the information. I'm going to be using Python. All of the code is going to be extremely modular, so I can do things like change the polling periods or change the tweet periods for aggregating the data, and just run the notebook again and have it spit out all of the information that I want summed up. And a key part of doing that efficiently is being able to present the information in a way that is easy and quick for people to understand. I'm going to go over key performance indicators really quickly because I've already talked about it. But the primary key performance indicator is the accuracy score of the model, which classifies the movement direction and favorability ratios and favorability ratings. The secondary key performance indicator is the mean squared error of the regression problem of predicting the actual magnitude of change in favorability ratings from one period to the next. And a tertiary key performance indicator, it's a little bit less precisely defined, but I want to extract topics and themes that are intuitive for a human being to read and not just random abstract concepts that aren't going to help somebody that's trying to get a brief summary of what's going on with the tweet. For previous research, researchers at Stanford used Twitter data to come up with like political moods for various policy proposals. We're going to look at trying to do the exact same thing, but we're going to try and find the political mood for a politician itself instead of a proposal. Now, for the data itself, the first data set we're going to get into is the polling data. For the polling data, we have 9,799 polls over 22 features from the day of inauguration of the president until pretty much last week, right? Most of the features I'm just going to erase because they're the same, like the president says the same over and over again, right? But the main ones that I want to hit on here are the start date of the poll, the end date, so that we can get an idea of when the poll is being done, sample size, the actual approve and disapprove, approval ratings. From there, there's a bunch of ratings and things that are aggregated together to create an adjusted approve and an adjusted disapprove. And I'm not sure which one I'm going to use. Basically, like they're adjusted based off of who the pollster is that's doing it, the grade of the poll, the weighting of the poll, the various groups that the people that are being asked these questions are being put into. So before I even use this data, I cut down on probably 5 of these features, and then I end up combining a couple of the other ones. All right, so after removing all of the unnecessary features and getting them in the right format for us, we have 17 variables, 10 numeric, 5 categorical, 1 date variable, and then 1 rejected. The rejected one we're not actually going to use in the model building process. I just used it for as a necessary component of visualization that you're going to see. You can see that we have 2 variables that are missing values. Grade is missing 2.8% of its values. Tracking is missing 47.7. The key to tracking is that tracking only takes 1 value. So, and then the rest are missing. So what I do is transform this into a binary variable so that a 0 means data is missing, and then a 1 means that data is being tracked. For the correlation matrix shown, the only real observation is that pollster, so who is running the poll, is pretty highly correlated with everything else. And that really goes to show how critical the specific party running the poll is, and how reliable we can take their poll. Something I'm going to be looking at is basically cutting out pollsters that aren't good and just using a good polls to see if that'll make it easier to predict favorability ratings. So this is just a quick this is just to quickly show you how the approve and the disapprove metrics for the polls are actually distributed. As you can see, they are all pretty like normally distributed. Looking at that, I don't have any qualms with not doing any other kind of extra transformation on it to get it into a decent shape. It's as normal as you could possibly hope for it to be. All right, so this is just a quick summary of a couple other variables in our data set. The first one is grade. The grade basically is a measurement of how good the poll is, right? What we can see here is that grades from C plus to B plus constitute about 83% of all polls. So really good polls are rare, really bad polls are rare, but C plus to B plus is what we can expect from most. Something to note here is that missing. For missing, all I did was impute the mode, so to get rid of the missing variable. Pollster. This shows you the most common pollsters that are used for the polling data. Ipsos, YouGov, and Rasmussen are by far the most common. Down here on the bottom right, you can see the histogram of start date. It basically shows you how many, it basically shows you like the start date of polls. The key thing here is that it's pretty uniformly distributed, so we're not going to have any issues where some days or some months have a very low number of polls. We're going to have sufficient poll numbers constantly throughout the whole year. This right here is a better representation of the polling size for all of the polls that are run. What you can see is that the median is about maybe like 1.7, 1.8 thousand people per poll. There are a couple that you can see that go way out. Like the data actually goes up to about 50,000 people per poll. So what I'm thinking of doing here is if I have issues reliably aggregating the data and making predictions off of them, I'm going to try and slice it off and only take ones that have a high number of people because those are more likely to be accurate. All right, so the next data set we're going to look at is the Twitter data. The Twitter data, it comes raw, super low key, super minimal. It's got the source of a tweet, it has the text of a tweet, has the date, time group of when the tweet was created, and then it lists if it was a retweet, how many people favorited it, how many people retweet it, and then like a random ID string that's associated with every tweet, which we're going to drop immediately. We have 15,000 tweets, and 15,000 is obviously a lot more than the number of polls, and it's obviously a lot more than the number of days in the last 2.5 years that the president has been in office, right? So what we're going to have to get into in a little bit is how to accurately aggregate these tweets so that we can still get useful information out of them. All right, so these are just a couple of quick visualizations to give you an idea of how the Twitter data is without actually getting into the content of the tweets, right? Up in the top left, you can see that the president has been tweeting more and more since he got in office. So the number of tweets that he's tweeting per day increases as his time in office increases. For the distribution of favorite count and the distribution of retweet count, it's clear that both are skewed right. And it pretty much just gives you a decent idea of how people interact with the tweet. The bottom right, distribution of tweet count by day. I just threw that in there to show, because I thought that the president would have 1 or 2 days where he would tweet the most and a couple of days where he wouldn't. But as you can see, Sunday is a little bit less than others, but in general, he tweets about the same amount on every day. All right, so these two word clouds are basically going to summarize two things. The left word cloud summarizes the common people or Twitter accounts that he's tagged in his tweets. And as you can see, he tags himself or he retweets tags that have him in them the most. Second to that is White House. So he tags the White House a lot. And third is Fox and Friends. So he tags Fox and Friends a decent amount in his tweets as well. On the right, it's the most common words that he uses in his tweets. When you see the big word link there, he doesn't actually type the word link in his tweets. That is when I do the pre-processing for the data, that is a hyperlink. So when he puts a hyperlink in his tweet, I just take that hyperlink and I replace it with the word link. Because the actual Twitter hyperlink is pretty there's no information that we can gain from that without opening up the page and downloading the information that's on the page for the hyperlink. After that, it's easy to see, great. He loves the word great. He likes the word people. He likes to talk about himself. So those are all things that I think we all know because we've all heard him say great 6 times in a single sentence, but it's interesting that it's reflected in his tweets as well. All right, for this slide, just a quick summary. The top left shows the most common tweet source. Most of his tweets come from an iPhone. The second most is from an Android. If you get into the research a little bit online, most people think that the iPhone is his personal phone, so tweets from the iPhone are from him, and tweets from the Android are from his staff. Next to that on the right, distribution of sentence lengths. As you can see, it's bimodal. He has 2 different peaks, and one of them is around 20 words. So he has a lot of tweets that are about 20 words, and then the other one is about 50. So he has also a bunch of tweets that are around 50 words per tweet. For the bottom 2, they use a Python package called Gensum, which is kind of like a dumb method of measuring subjectivity and polarity in text. It doesn't use anything crazy like neural networks. It basically is just like counting, assigning each word like as positive or negative, and then counting it out, right? But for subjectivity basically, if it goes from 0 to 1, 0 means that a tweet is pretty objective. 1 means that a tweet is pretty subjective. As you can see, he has a lot of tweets that are completely objective according to the Gensum package. But for the most part, the subjectivity ranges it is centered around 0.5, and it's a very wide distribution out from there. For polarity goes from -1 to 1. -1 means it's a negative tweet. +1 means that it's a positive tweet. 0 means that it's neutral. He has a huge spike around 0. So most of his tweets are neutral. But then you can see that there's also a wide distribution out from a center. But this one is shifted a little bit to the right. So most of his tweets, or the majority of his tweets, have somewhat positive sentiment to them. Positive sentiment. As I said, this method isn't generated from the data, so it's more of like a quick check instead of being an actual this is good sentiment and this is good polarity. All right, so next up is how we aggregate and combine the data. What we're going to do is we're going to generate something called a poll period. The poll period is going to be a feature that basically is a grouping of days. So a poll period of 3 means that we aggregate all the data in 3-day increments. A poll period of 1 means that we just aggregate all the data that's in 1 day together. A poll period of 7 means that we put everything from a week together into one row of data. So for the transformed and aggregated polling data, after we transform and aggregate the polling data with a poll period of 1, we have 979 rows of data with 82 features. The majority of those 82 features are dummy encoded variables. you can see right here that 0.13% of all rows have different favorability and adjusted rate changes in favorability. So the difference between favorable and the adjusted favorable rating is they're pretty similar. We have the polling aggregation rules here. Essentially what this does is it maps a variable to the function that aggregates it. So for poll period, first just basically means that since we're aggregating around poll period, it takes the first value that it comes across in the data set, which really it could take any of them, because when we aggregate them, all the values of the variable that we aggregate around are going to be the same. For grade, that is the grade of the poll. What we do for that is we take the mean. I would take the mode, but there's not a quick and easy way of taking the mode in aggregation using pandas. For sample size, we take the mean, which means that for our aggregated data, we take the average of the sample sizes and say, this is what the sample size is. For influence, again, we take the mean. So we take the mean of all of the influence, and that's what it is for the aggregated period. For favorite, adjusted favorite, all of those, again, we take the mean. For tracking and the number of polls, we take the sum. So what it does is it sums up the number of polls that are being tracked when we aggregate, and then it also sums up the number of polls that are in the aggregation. So the number of polls variable after aggregation is going to tell us the number of polls in that current polling period. And then for each of the dummy variables underneath of it, we essentially just add them all up. So it'll tell us how many times each polling organization has a poll in that poll period of aggregation. All right, so for the Twitter data itself, once we transform and aggregate it, we have 977 rows over 21 features. The rules for transformation are shown here too. It's a little bit more complicated, but not by much. So for retweet and favorite count, we just sum those up. So for any poll period, we just sum the number of tweets and retweets that are in that poll period together when we aggregate the data. For the is it a retweet, we take the mean. So it'll tell us the average number of polls that are the average number of tweets that are retweets in a poll period. Same thing with hour, we take the mean. It tells the average hour of tweets in that poll, the average hour of each tweet in that poll period. For word count, we sum it up. For tag count is the number of people he tags in a tweet. Same thing with hash count, it's the number of hashtags he uses in a tweet. So for the word count, the tag count, the hash count, the number of tweets itself, those are all just summed together. For subjectivity and polarity, it's a little bit more complicated, but essentially what we do is take a weighted average of the subjectivity and the polarity. So so it's weighted by the word count of each tweet, and essentially it works like this. So if you have a tweet, a very negative tweet that has 50 words, it's going to have a bigger effect at dragging down the polarity of the tweet than if you had a negative tweet with 5 words, right? So how much the polarity and subjectivity of each tweet affects the overall score is judged by how long the tweet is. And for text, we concatenate the strings together. So literally, we just take all of the text in each tweet and we just put it all together into one big paragraph. It's not as sophisticated, but it works. All right, so after we've transformed and aggregated that data, we merge it together. The merged data with both the polling and the Twitter data in it has 966 rows and 102 features. A key thing to remember is that most of those features are just dummy variables. We don't actually have like 102 like dense, rich features. We have dummy variables for the source of the tweet, so where the tweet came from. For the sub, where basically the categorization of the people that are in the tweets, the pollsters. So each pollster has its own column, and it just is 1 or 0 depending on whether that pollster has a tweet in that aggregation period, and for the population group as well. Outside of that, it's just basically the variables from both of the previous transformed aggregated data squished together. On the bottom, there's 2 graphs that basically show the number of tweets per aggregation period and the number of polls per aggregation period. For this presentation, the aggregation period is 1. So the number of tweets per day is about 9 or 10, and it's skewed right. So the president either tweets or retweets about 9 or 10 tweets a day on average. For the number of polls per aggregation period, again, it's about 9 or 10, and it's skewed right. Not as bad though, it's decently normal, which means that on any given day, there's about 9 or 10 polls that have been conducted to measure favorability ratings. Hopefully, the fact that there's 9 or 10 polls per day is gonna smooth out the random motion of favorability enough that that we can get decent results out of it without having to resort to more drastic measures. More drastic measures would mean like aggregating the polls like weekly, so that we aggregate all of the polls in a single week together, and we use the model. It tries to predict the favorability rating the next week from any given day's worth of tweets. That's not as responsive as I would like, so we'll see how that works. So now we look at the target variables for the transformed and aggregated data. On the right, the two plots on the right basically show the distribution of the category, the change in favorability category. For this, 0, it's a binary problem. 0 means that his favorability rating has decreased. 1 means that it stayed the same or increased. Something cool for this data is that both the adjusted favorability and the regular favorability are about evenly distributed. So we don't have to do anything crazy like using weighted cost functions or anything like that, because we have about a 50-50 split. Similarly, on the right, it shows the actual like favorability change, the magnitude of that change, and the magnitude of the adjusted favorability change. And the cool thing here is both of them are almost perfectly normal, like perfectly normal, which I love. And it means that we don't really have to worry about like any type of like crazy transformations to get the data normal. Like the distribution of favorability change, the magnitude of favorability change is perfect for polling periods of a single day. All right, this last slide is basically like a quick thing to show relationships between the variables and the merged data. It's a heat map of the correlation matrix. The key thing to take away here is that none of the descriptive variables that came from the Twitter data set are either high or lowly correlated with any of the favorability ratings or any of the target variables that we have. Basically means that it's not going to be easy. This thing is going to fight me. It's not like I can just look at the polarity and the subjectivity of tweets, and that will determine how his favorability is going to move. It means it's going to be very highly dependent on the actual text data itself. So that's pretty much it for my presentation. Thank you all for paying attention. I would love feedback on how you guys think the project is, how my presentation goes, and everything like that. Have a good day.